Today we are going to continue with our methods of preparation of amines. We have already discussed in our previous video the first method of preparation of amines, that is from reduction of nitro compounds. This method we have already covered up. The second method which we discussed was ammonolysis of haloalkanes. Now what is this ammonolysis of haloalkanes? We have already seen. It means we are going to break the bond of haloalkanes Rx with ammonia. So here the drawback which we faced in this method was that we were getting a variety of products. We got primary amines, secondary amines, tertiary amines, and finally we got salt. So these are the 4 products which we are going to obtain by using this technique. And how to obtain only primary amine by this method is by using excess of ammonia. So that can be a question for you in the exam. How to obtain primary amine by ammonolysis? So the answer is by using excess of ammonia. For example, if you are using 10 moles of Rx and 50 moles of NH3, then definitely Rx will act as a limiting reagent for us. So when Rx and NH3 react, definitely we are going to get RNH2. We are going to get primary amine 10 moles, and after that the reaction will be almost stopping because now we have still 40 moles of ammonia left. So this is how we can talk about as the first method. Now in today's video, let's cover up the remaining methods of formation of primary amines. The third method is reduction of nitriles. Now nitriles are also known as cyanides in their common name. Alright, let us take a simple example of this. Like for example, if I am writing RC triple bond N, then this compound will be read as alkyl and this portion will be read as cyanide. This is going to be your common name. Like for example, if I write CH3C triple bond N, then in the common name I am going to name this compound as methyl cyanide. This was your common name. Now if you want to read out its IUPAC name, then it's going to be, you're going to count both the carbon atoms over here. So when you count these both the carbon atoms, then it becomes alkane, and then the nitrogen will be read as nitrile. Alright, so similarly, like when we talk about these, we'll have 1 and 2 carbon atoms, so that becomes ethane, and this nitrogen will be read as nitrile. So we are going to reduce these nitriles by using different reducing agents. The most common reducing agent which we all use always, you must have seen, is catalytic reduction technique, wherein we are going to use hydrogen gas on catalysts like nickel, platinum or palladium. So in all the reactions of organic chemistry, if you want to reduce this catalyst, this reagent you can use. Apart from this, we can also have some more reagents like lithium aluminium hydride, which is also written as LAH, or we can have sodium metal plus ethanol, which can be written as ETOH. Now what's the meaning of ETOH? It means C2H5OH. or sometimes in the textbook you would find sodium amalgam plus ethanol. So all these are the common reducing agents, children, but frankly speaking, any of these three can be given in the exam, and by looking at the reagent itself you should understand that they are talking about reduction. Like for example, here we have sodium and alcohol, so hydrogen gas is going to be released out. So hydrogen is going to be used for reduction of these compounds, cyanides. Now we have two double bonds, so naturally we are going to add, for one double bond we add two hydrogens. So here we have two double bonds. So we are going to add two hydrogen from that side also. So as a consequence, we are going to get the product as RC single bond N and H2H2. So that becomes your amine, and it is going to be a primary amine. A primary amine is the one in which the nitrogen is attached to one carbon atom. So that's your primary amine. Let's take example. For example, we are going to take this compound phenyl cyanide. Alright, so this is phenyl and that's your cyanide. So phenyl cyanide we are going to take, which is very common compound used in your textbook as well as in the exam. Its IUPAC name can also be, now this was your common name and this is going to be your IUPAC name, benzonitrile. Now this compound I am going to reduce using any of the reducing agents which we discussed. Let's use catalytic reduction technique. So what product are we going to get here? You can easily guess. We are going to reduce this cyanide group, and we are going to get benzene with CH2 NH2. That's your benzyl amine, and you can see that it is a primary amine because the nitrogen is attached to only one carbon atom. This is going to be your common name, children, and when we talk about the IUPAC name, it's going to be, we are going to call this as, phenyl. This is phenyl and the NH2 is attached to this, so it's methane. This is your parent compound, right? So we can call it as methane amine. We are not going to write the E over here, we are going to remove the E, alright. So it's going to be phenyl methanamine. So that is how, this is a very simple method of preparation of amines from cyanides or you can say nitriles. Similarly, we all are aware that these are isocyanides. Isocyanides are the isomers of cyanides. So this is going to be your alkyl isocyanide. So we can also reduce our isocyanides with the same reagents as we discussed above, and we can have like RNC and we can have HCH3. So in this manner, what we are going to do is we are going to achieve the formation of 1 and 2. You can see that nitrogen is attached to 2 carbon atoms, so we are going to get secondary amine. So by the reduction of cyanides we are going to get primary amine, whereas by the reduction of isocyanides we are going to get secondary amines. So this is very simple. Let's go to the next method. The next method is reduction of amides. Now we all are aware of what are amides, what is the functional group of amides. So here we have the general formula like CONH2. Children, this is the general formula of amides, where you can see that the nitrogen is attached to only one carbon atom. So we can call this as a primary amide. Similarly, we can have, instead of one hydrogen, you can put one alkyl group. So that becomes secondary amide because the nitrogen is going to be attached to 2 carbon atoms. So that becomes secondary amide. Of course, we can guess now the third one is going to be a tertiary amide because we can attach 2 more alkyl groups. So 1, 2, 3 carbon atoms are attached to nitrogen atoms. So that becomes your tertiary amide. So basically in the class 12th, we will see that this example is mentioned in the book, but we may also use secondary amide and tertiary amide for the reduction process. Now for reduction of these amides, the reducing agents which we are going to use is very simple. We are going to use lithium aluminium hydride, and second step we are going to hydrolyze this with water. When we do that, the process is very simple. We are going to just change the C double bond O to CH2. So wherever we see the carbonyl group, we are just going to reduce it CH2. So naturally my answer would be changing. So I can just remove this and write here CH2. I can remove this, write CH2, and I can remove this and write CH2. So it's so simple like that. And so here we get primary amides are going to get converted into primary amines. Secondary amides are going to get converted to secondary amines, and the tertiary amides are going to get converted into tertiary amines. So that's the process. We can take some example also for this. I will take a very simple example over here which is common in your exam. This is a very famous amide, aromatic amide, which is called as, it's benzamide. It's coming from benzoic acid. We can see here that this portion has been brought from benzoic acid. Okay, so when we reacted benzoic acid with ammonia and heated it, we got benzamide. Benzamide, now we are going to heat it up with lithium aluminum hydride and subsequent hydrolysis, so that it gives you phenyl methane amine, or you can say benzylamine, which is a primary amine. So that was your method, which was quite simple. Now we are going to discuss one more important method which is related with amides itself, and that method is Hofmann bromamide degradation. So this method is always generally asked in the board exam as a name reaction, and it's a very famous method of descending the series. As we can see, the name itself suggests degradation, which means that we are going to degrade or we are going to break down a compound. So this is an example of descending the series. Whenever you lose carbon atoms during the reaction, from let's say 4 carbon atoms parent compound, you're jumping to 3 carbon atom products, you're losing carbon atoms, right? So that's called descending the homologous series. Let's take this example itself. So here we can take an amide. See, we are in the name itself, you can see there's an amide. So we'll take an aliphatic amide or an aromatic amide. Primarily I'm taking now an aromatic amide, benzamide, and we're going to react this with bromine and potassium hydroxide or sodium hydroxide, alcoholic, or you can also take aqueous KOH also, and heat this up. Naturally, when we heat this up, the mechanism of this reaction, of course, is not going to be asked in your board exam. So it's simply, when we want to write the short note on this, or just we want to make it clear what is it, it will be simply the migration of the aryl part from the carbonyl carbon to the NH2. So we are going to migrate the alkyl or the aryl part, in this case aryl part, from the carbonyl carbon to the NH2. So what we get is, we get the aryl part now directly connected to NH2. That's your primary amine. Aniline, that's the name of that compound. And the remaining products which are visible to us, we can see easily what are the products here. So we are going to get here KBr, of course, we can see, right? We can see CO is coming out, so it's going to be reacting with KOH, so it will be getting K2CO3. Water is also going to be coming out. So we need to practice this reaction so that we can write it in the exam first of all. So that's the Hofmann bromide degradation, and as we can see, balancing is not required for the organic chemistry in the board paper, whereas for inorganic chemistry, yes, of course, it's required. Now children, Hofmann bromide degradation is applicable to only primary amides and both aliphatic as well as aromatic, which means that if I just replace this with an aliphatic compound, something like this, then your product is simply going to be CH3 and H2. So that's the same way as you did for aromatic. So Hofmann bromide degradation is a kind of method wherein we are losing carbon atom number 1 from the parent compound. We are losing one carbon, so it's called as descending the series. Let's go to the next reaction. So now we come to the last method of preparation of amines, that is by Gabriel Thalamide synthesis, also written as GP synthesis. This is one of the best ways, excellent ways to prepare primary aliphatic amines. So you're going to prepare primary aliphatic amines by this method. Now what is the meaning of primary? We all know that the nitrogen is just connected to one alkyl group. Alright. Aliphatic means that it has to be a straight chain compound, which will be either an alkyl part coming from an alkane, or it can be a part coming from alkene, or it can be a part coming from alkyne. Most of the times, 99% will see in our books, most of the times it is alkyl which is coming from alkane. So let's see the Gabriel Thalamide synthesis. As we can see here, we are going to use the raw material as Thalamide. So children, you have to practice the structure of Thalamide, how to draw it. Just it's very simple. So we are just going to write here N and H. That's your Thalamide. Now when we look at the structure of Thalamide, we can see that there's a lone pair on the nitrogen atom which is in conjugation with the double bond. The meaning of conjugation is that they are alternately placed. So we can read the lone pair of electrons as double bonds. So it's a double bond because in the future it's going to be a double bond. So it's a double bond, single bond, double bond. Same way here also, double bond, single bond, double bond. So because of this, the electrons get involved in resonance from the top, as well as the same thing can happen at the bottom also, right? So there is going to be a kind of electron withdrawing effect taking place on this side. Because of this electron withdrawal, the electrons of hydrogen atom also gets pulled towards nitrogen atom. So we can always state that due to two electron withdrawing groups, that is carbonyl groups present in Thalamide, the hydrogen becomes deficient in electrons, and that kind of hydrogen is known as acidic hydrogen, or we can also call it as proton. All right, so this is something very important for us to understand. Now we are going to react this acid with a base like potassium hydroxide, or we can use sodium hydroxide. We all know that wherever we use KOH, we can also write NaOH also in the exam. So acid and a base react together to form water. So this H and this OH is going to come out, and what we get here is going to be, now remember these three lines which we are showing the pi bonds, also we can draw a complete electron cloud like this. All right, so it doesn't make a difference if you write it this way or this way in the exam. So now we have got CO, and naturally children, this H has gone out without its electron pair, right? So these electrons will be now shown on nitrogen atom by drawing a minus sign, and the potassium will be written here as plus. So a cation and an anion means it's a salt. So this is a salt of Thalamide, so we can write it as potassium Thalamide. All right, so this is not very challenging for us to remember in the exam. Just apply your logic. And now we are going to react this with the reagent, that is alkyl halide, and we all know how alkyl halides they are having a negative and a positive. They have a positive and a negative sign like this, right? So we can say that this nucleophile can attack this electrophilic carbon atom, and this X minus can be going out. So this is a kind of nucleophilic. So this nucleophile is going to be substituting the X nucleophile, right? So this nucleophile comes and the X minus goes out with the K plus, so we get minus Kx. So children, this is a kind of nucleophilic substitution reaction, remember that, alright. So nucleophilic substitution reactions, we've already studied in the chapter haloalkanes and haloarenes. So just a minute. So we already studied this SN1 and SN2. So this is going to be a kind of nucleophilic substitution reaction. What product do we get after this? We can always draw it this way, C double bond O, C double bond O, and then we get N and NR, something like this. Now here we need to draw these bond over here because it's a covalent bond. What is the byproduct? We've already written. So this product is going to be now called as N-alkyl because we have attached the alkyl group on the nitrogen atom, so it will be read as N-alkyl thalamide. The final step in most of the reactions or organic chemistry reactions is breaking the bond. Okay, so we are going to break the bond using water and catalyst H2SO4, slight little drops of H2SO4 you're going to add. So this kind of hydrolysis is going to be called as acidic hydrolysis. When we break this, you remember that we are going to break it this way always, all right. So the carbon nitrogen bond breaks and the product obtained would be C double bond O and C double bond O like this, and from that side we are going to get R and N. So this is the product which is going to come out, and whenever the bond of carbon and nitrogen breaks with water, the carbon takes away the hydroxyl groups and the nitrogen takes the hydrogens. So this is going to be your product, that's your primary amine, you can see. So we get a primary amine as the major product. So Gabriel thalamide synthesis is a superb method for production of primary aliphatic amines. This is an industrial method, and as you can see we are getting phthalic acid generated over here, and this phthalic acid can be reused, recycled, and it can be used to further prepare thalamide. So phthalic acid is going to react with ammonia to form ammonium phthalate salt, and ammonium phthalate salt on further heating will give you thalamide. So in this way this process looks quite good, economical. Secondly, there is an important question which is asked in the board exam. Can we use this method for production of primary aromatic amines? Can we use this? So if we want to use this method for primary aromatic amines, children, we'll have to write here we'll have to write here haloarine like this. And we all know very well that haloarenes, if they are attacked this way, this bond will never break. So haloarenes do not undergo nucleophilic substitution reactions under normal conditions. Due to partial double bond character between carbon and halogen atom, they do not undergo nucleophilic substitution reactions easily. So this is what we are going to write in the paper. The keywords over here are going to be partial double bond character due to resonance, and haloarenes do not undergo nucleophilic substitution reactions. So this method is only restricted to the preparation of primary aliphatic amines and not aromatic amines. So with this we finish our today's topic of preparation of amines. I'm sure you have understood this. It would be advisable for all of you to go through your exercise questions. Organic chemistry can be mastered by revising a lot, doing a lot of practice, and as many questions you can solve from your textbook, you would be finding it easy. And as we all know, in the 2022-23 exams, you're going to get lots of questions based on your MCQs, assertion reason, case based. So keep on practicing more and more. Thank you so much. Keep studying. See you soon.